You've been there, right? You go to save a picture and you're hit with that drop-down menu, a whole bunch of weird acronyms. It's a choice we make almost every day. But what does it all actually mean? Well, today, we're going to unravel the story behind our images. Yeah, it feels like they should all just work, right? But the thing is, the format you choose can totally change everything, from how big the file is to how good the picture looks. So let's dive into how we got here and what problem each of these formats was actually designed to solve. All right, let's jump in the time machine and head way back to the 1980s. Forget the internet for a second. The first huge fundamental challenge was just, how do you even store a picture on a computer in the first place? So 3 early pioneers stepped up to the plate. First, you had TGA, which was built for the creative pros. It gave us the alpha channel, a clean way to handle transparency that's still a standard in things like video games today. Then there was PCX, the star of the early PC world, with a really smart new trick to shrink files. And finally, Microsoft's BMP, the simplest of them all. It was just a raw, uncompressed map of every single pixel. No tricks, which meant the files were absolutely enormous. So what was this clever little trick that PCX used? It was called run length encoding, or RLE. And the idea, for its time, was kind of revolutionary. Instead of saying white pixel, white pixel, white pixel 50 times in a row, the file could just say, hey, 50 white pixels right here. For the simple graphics back then, this one idea made files so much smaller and really laid the groundwork for all compression to come. And then, bam, the internet arrived. And with it, those screeching, slow-as-molasses dial-up connections. Suddenly, those huge, clunky files from the 80s were just not going to cut it. We had a whole new set of problems that demanded a brand new generation of formats. So who was the first hero to save the day on the slow, early web? None other than the GIF. It was pretty much perfect for its time. The compression was good enough, and it gave us animation, which, let's be honest, is a cultural phenomenon that's still going strong today. But here was the catch. It was limited to only 256 colors. That's why GIFs look great for simple cartoons, but kind of rough when you try to use a photo. But then, in 1992, JPEG comes along and just flips the whole table, especially for photography. A group of engineers got together and took a radical new approach. They asked a really brilliant question. How much data can we actually throw away before a human eye even notices? This whole idea is called lossy compression. And honestly, the best way to think about it is like vacuum sealing your clothes for a trip. You can cram way more into your suitcase, right? But when you unpack, everything's a little bit wrinkled. A JPEG isn't a perfect replica, but it makes the file so much smaller that it's almost always worth it for photos. And just like those clothes, every time you open and resave a JPEG, you're basically squishing it again and adding a few more wrinkles. So, just as everyone's getting comfortable, a bit of drama kicks off. The company that owned the patent for the GIF's secret sauce announced that, hey, developers were going to have to start paying royalties. And the early internet community, in this beautiful open source spirit kind of way, basically said, fine, we'll build our own, and it'll be free for everyone. And just like that, PNG was born. Now, unlike JPEG, PNG takes a totally different approach. It uses what's called lossless compression. Think of it like a perfect zip file for an image. You make it smaller to send, but the person on the other end unzips it, and it's an absolutely perfect pixel-for-pixel copy of the original. No wrinkles, no data thrown away. This is absolutely crucial for things like logos or screenshots, where every single detail has to be crisp. Okay, so let's put these 3 titans head to head. JPEG is your go-to for photos. It handles millions of colors. But remember, its compression is lossy. It gets wrinkled, and it can't do transparency. GIF is for those fun, simple animations, but it's stuck with just 256 colors, and its transparency is just basic on or off. And then you've got PNG. It's the master of graphics with perfect lossless quality and that really advanced graded transparency that looks so clean. All right, let's fast forward to today. Our internet is way faster, right? But the websites we visit, they're huge, they're bloated. And those amazing formats from the 90s are now actually part of the problem making pages load super slowly, especially on our phones. And get this is how big the problem is. On an average web page today, a whopping 60% of the total file size is just images. That is a massive amount of data your phone has to download, and it's exactly why we needed a new generation of formats. So naturally, we needed some new heroes. Enter the next-gen contenders, Google's WebP, the super-efficient AVIF, and the powerful JPEG XL. Their one big mission? To deliver that amazing quality you expect, but at a tiny fraction of the file size. They pull this off by using way more advanced tricks, borrowing ideas from modern video compression to make the web feel fast again. And you can see here, the results are pretty wild. Compared to an old JPEG, WebP gets you a solid 30% smaller file. But then you get to AVIF and JPEG XL, and we're talking about cutting the file size in half or even more. That is a huge deal for web performance. But, the web isn't the whole story. In professional fields like medicine and scientific research, the priorities are completely different. It's not just about what the picture looks like, it's about the mountain of data that's embedded inside it. Take a look at this. This is the header of a DICOM file, the absolute standard for medical imaging. The #1 rule of DICOM is that you can never separate the image from its metadata. It packages everything, patient information, scanner settings, you name it, right into the same file for clinical use. But then you have researchers, and they have a different set of needs. So they'll often take those clinical DICOM files and convert them into something called NIfTI. NIfTI is way simpler. It strips out all the sensitive patient data, and it can combine hundreds of those 2D medical slices into a single 3D image that's much easier to analyze. So really, it all boils down to the job they're built for. DICOM is complex, comprehensive, and built for the clinic. It's what comes straight out of the scanner. NIfTI is simplified, anonymized, and built for the lab, perfect for analysis and sharing among researchers. 2 different tools for 2 very different jobs. Okay, so after that whole trip through history, what does this all actually mean for you today? With all these choices, picking the right one might seem complicated, but it really doesn't have to be. Here's a super simple way to think about it. For photos on a modern website, try to use AVIF and have WebP as a backup. For logos or anything with sharp lines and transparency, PNG is still your best friend. For archiving your professional photos where quality is everything, you want TIFF or your camera's RAW format. And if you just need something that's going to work absolutely everywhere on any device, no questions asked, yep, good old JPEG is still the universal language of images. And hey, one last thing, a really quick privacy tip for you. A lot of image formats, especially JPEGs from your phone, have hidden data baked in, including the exact GPS location where you took the picture. If you want to share a photo without sharing that info, the fastest, easiest way to strip all that out, just take a screenshot of your own photo before you share it. The new file is completely clean. So we've gone from simple grids of pixels to these incredibly complex data packages. Image formats have always evolved to meet the next big challenge, which leaves us with a pretty big question. As AI starts generating more and more of our visual world, what's the next big problem that image formats are going to have to solve?